Alright, this video is on the mole. Okay, a mole is it's a unit. Okay, and it's a word that we use to associate with a number. If I was to tell you dozen, right, the word dozen, that is associated with the number 12. If I said pair, that word is associated with the number 2. Um, the word mole is associated with a number known as Avogadro's number, which is 6.02 times 10 to the 23rd. Okay, so when you say a mole, I'm referring to this number. Right, just like if I was to say a dozen, I would say 12. If I was to say a pair, I would say 2. But Avogadro's number is 6.02 times 10 to the 23rd, and that is the number that is equivalent to 1 mole of something. Now, the reason why we deal with the mole in chemistry versus looking at individual atoms is that we can't really look at individual atoms um, in a laboratory setting, but we can look at the mole of atoms or a mole of atoms in a laboratory setting because the amount of matter or the mass of that matter is going to be in units that we can actually measure, so grams, so to speak. But what you're going to do is, from your reading, okay, in chapter 6.1c, that goes into how we can use the mole, um, you'll have problems such as, let's say, if um, I had 2 moles of helium, right? I wanted to know, well, how many atoms of helium is that? So if I have 2 moles, I would put moles over 1, and I know that 1 mole of helium is equal to 6.02 times 10 to the 20, oops, times 10 to the 23rd atoms of helium. Okay? And then I'll cancel my units out, and if I wanted to find out how many atoms of helium are in 2 moles of helium, I would just multiply 6.02 times 10 to the 23rd times 2, okay? And I would get 1.20 times 10 to the 24th atoms. Now, in this case, I'm ignoring sig figs just because I forgot to make this 2.00. So making that 2.00 moles, I would end up with 1.2 times 10 to the 24 atoms of helium. Okay, and obviously that's a huge number. Okay, that's 1. Okay, with 23 more zeros afterwards. All 0, 0, 0, 0, 0, 0, 0, all the way, big number. Okay, well, we can actually mask these big numbers because when we're looking at individual atoms, we use the unit AMU, which was tiny, 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 tiny. But now that we're looking at not just 1 atom of something or 2 atoms of something, and we're looking at moles of something, the unit for a mole, we can use grams, and we can measure grams on, say, a triple beam balance. We can measure how many moles are there based on its mass. So it kind of brings us back to the counting by weighing, but this time we can make our weight or our masses in grams, and then from that we can determine not only the number of moles, but also the number of atoms that are in a sample.